Last night we had the speaker dinner, and afterwards they gave us espresso, which is a very nice touch, but I'm very sensitive to coffee, so I didn't sleep very well, which is fine for this talk because I slept in. But I lay thinking, and I don't know if you've ever been to the kind of talk where somebody presents, usually it's a JavaScript library, somebody presents something that they made or that they read about. It's kind of neat, but when you listen to them present it, and when you go through the whole presentation, at some point you realize this is not a good idea. Like, this is a bad idea. Like, we don't want web development to go in this direction. I don't know if any of you ever had that experience at a talk. Nobody? All right. Well, I realized last night that this might be one of those talks. So I decided to add a bit of a disclaimer that I'm going to present, next to some information about what is important in web page optimization, a project that is a bit of a Band-Aid. When you have the opportunity to start building your application and you can think about performance from the beginning, you're not going to need this. It's something that if you have a legacy app and you don't want to rebuild it for performance first, then you can add this and it can solve some of your problems. But it's not going to make everything perfect. But that's kind of a recurring topic in software development. We never have time to really think about doing everything perfectly. So we keep adding layers upon layers in order to get something in the end that actually works, right? Because we have a lot of JavaScript on our pages. We get faster JavaScript engines. So what do? Add more JavaScript. So there's the eternal balance of performance in that sense. So that's the diagram for that. All right. I think it's a familiar story for some of you, at least if you're contractors or if you're working for an agency or something like that. I've been doing contracting for about a decade, and I have a lot of customers that ask me about performance. That's the topic that just keeps coming back. And my site is slow. What can we do about it? How can we improve it? And it's important to the customer because it's important to their customers in the sense that if you have a slow site, it's not good for your conversions. There's lots of research showing that. One sample is that a high percentage of users will leave if it takes longer than 3 seconds to show a usable page. That's on mobile. But similar percentages apply on desktop. And there are other findings like 100 milliseconds increase in latency causing conversions to drop by 7%, which is ridiculous. Of course, that's only in certain points on the curve of conversions versus latency, but still, that shows that performance improvements can make a huge difference in your conversions, which are important to your customer, obviously. And lastly, the reason that I like performance optimizations is that I really hate working on slow sites. Because you change something, you have to reload it, it's really painful. And if you're clicking around in order to test some functionality, it's the same stuff. So personally, that's the main reason I care. So people usually find out about this stuff because they use some tools. GTmetrix is kind of popular, but the tool that probably all of you have heard of and used is Google PageSpeed Insights. Who hasn't used this tool? All right, so that's 2 people. At least 2 people that want to put their hands up. In my experience, lots of clients learn about performance first when they use this tool. They never have thought themselves, oh, my site is kind of slow, unless it's really bad. No, they put it through the tool, and then Google gives them a bad grade, which is kind of like a report mark at school. And Google says your site scores 60 out of 100, which is obviously not very good. And Google's opinion is important to them because they know that Google cares about speed for SEO purposes, right? So what these tools do is they use some heuristics in order to generate a score for a web page. Not a very large part of the score. In Google PageSpeed is a small part of the score, and GTmetrix is not a part of the score. Only a small part of the score at most is the actual load speed measured. Most of it is heuristics. But those heuristics generally do a pretty good job at predicting the load speed. Well, this is a report from a client site. What we get 22 out of 100, which is obviously a bit demoralizing. So you get the reaction. Whoops. Google grades my site badly, which has a strong psychological impact on the customer, whether or not the actual experience of the user is very bad. And that's why, as developers, I've seen it. I don't know if you've ever done it yourself. You probably haven't, of course. Dismissing the information from the tool by saying, you know, the score is really bad, but in fact, none of the things that it says are really that important, and that's why it's fine as it is, or I don't have to actually do those optimizations. Will anybody admit to having said that at some point to a customer? Right. So that's what I used to do as well. Like, the first thing I try to do in this journey is to re-educate the customer and say, you know what, these things are just tips, and they're not that important, so we're not going to do it because it's not worth the effort. But hey, they're not that happy with that, so I wasn't terribly successful at that always. And there is a point to not being terribly successful at that, because although it's true that not all sites that score badly are very slow, because there are a number of heuristics that don't make that much sense, like Google PageSpeed Insights has a fantastic one, which is levered browser caching, and you see in the second line that it's not happy and it won't give you a perfect score because of Google Analytics. So you can get rid of Google Analytics to solve this. So I have the feeling that in Google it's not always perfectly coordinated between teams. But where is it anyway? But generally, the relationship, the correlation holds. Like if you get a perfect score on the tool, then you can be reasonably sure that your site will actually be pretty fast. Google PageSpeed Insights used to be kind of pretty simple. It used to have 9 rules, 9 simple rules, relatively simple rules, that together made up with certain weights distributed across the rules that made up the score. These days, they use another different tool called Lighthouse under the hood, which is also available as a Chrome extension. Like, it's installed by default, actually. It's pretty neat. It doesn't only check for performance, but also for accessibility, SEO, whether your site is a progressive web app, and some JavaScript best practices. But we're not really interested in those. However, they now have 26 rules for performance, which we are going to go over now one by one. No, we're not. Thank God. Luckily, you can more or less categorize those, with a few exceptions, as rules regarding latency, bandwidth, and round trips. Latency meaning the amount of time that the client needs to get a particular resource from the server, which obviously is a bit of a, before you have a resource, nothing is going to happen. So before you get the HTML page, nothing is going to happen. So if you have slow server response, you're dead already. The other thing, we're talking about minification of resources and image optimization and so on. That's all bandwidth minimization, especially important on mobile, because if you have slow connection, there's going to be a strong difference arising from the size of the resources, like images that need to be downloaded. On desktop, it's less important. I mean, these days, we all have fiber connections. So unless one is on a slow ADSL connection, there won't be much of a problem, even if a few resources are a bit bigger. The most interesting part to me is the round trip story, which has to do with the amount of times that the client has to go back to the server in order to get some middle puzzle piece in order to be able to render a page. You're generally talking about CSS and JS. We'll go over that. For example, you're thinking you have a style sheet. And sometimes those style sheets might import other style sheets, and those imported style sheets might have a web font. At this point, the client first goes to the server, gets the style sheet, and then the style sheet says, yeah, but you need this other one too. So it has to go again. And then the style sheet says, oh, you need the font. So it has to go again. And only after it comes back the last time can it finally actually render the page. So then, if you have 100 milliseconds needed in order to get a resource, suddenly it's 400 milliseconds, in the best case. So a simple diagram that I think you should be familiar with. I'm going to go over it anyway because because it's fundamental to the whole story. The way that web pages are built up and loaded is, of course, there's HTML, which refers to other resources, some of which are loaded synchronously, some of which are loaded asynchronously. After the download of the HTML, anything that's in the head, CSS and JS resources, are going to have to be downloaded before anything can be rendered. I'm sure that most of you are aware of that. Additionally, you can have images and async JS on your page, which doesn't have to be downloaded in order for anything to be rendered. Because it's done simultaneously, and it doesn't block the rendering. There is a little bit of a thing there that async JS can slow down your site because, of course, it's kind of hogging bandwidth that is not used at the same time for downloading other resources. And especially in mobile devices, JavaScript execution is not as cheap as you think. And it can block the CPU and delay interaction with the page and delay rendering as well. This looks a lot like a waterfall diagram that you can get yourself for your own websites using free tool webpagetest.org. I don't know how many of you have used this. Yeah, so that's, I guess, about half. It's very useful. Basically, it's the only tool you need for proper, like real performance optimization, as opposed to heuristics-based checks that you have with PageSpeed Insights. So you put in your URL and you get a report. And it's a pretty big report. There's some metrics at the top. Oh, wait, where's my mouse? Oh, yeah. We've got these metrics, which are numeric, but the most interesting thing is a picture, which is this. And this one is not pretty, because what you're looking at, the green line is when the render happens. What you're looking at is download a page, and you need to have all these other resources in order to finally, when the last JavaScript has been downloaded, executed, finally get a render. Now, of course, if it looks like this, on desktop, well, 1.7 seconds. It's not good, it's not pretty, but all right. But if you're doing this on mobile, it's going to be a massacre. What you want it to look like is more like this, where, in fact, here, this is mostly due to CPU, like parsing the page and actually laying out everything. As you can see here, the CPU usage. But in fact, the page can be rendered right after the first HTML has been downloaded. And it's just waiting for a couple of images. But it doesn't have to wait for the images. So if the images are loaded slowly, the page will be rendered nevertheless. The statistics that you see at the top here, pretty useful. Although people usually stare themselves blind, at least that's how we say it in Dutch, on the load time. But the load time isn't always relevant because it's waiting also for images to complete loading. What you're mostly interested in is the start render time, which is the third column, and the visually complete time. Especially visual completion, that means that everything that's on the page isn't going to change visually after this moment. So there's basically the 2 seconds of load, something is happening, but it doesn't matter. It doesn't influence what the user sees. And we're basically interested in perceptual load speed. So we don't care so much about whatever's going on in the background. We care when the user feels like something is happening. And when you make sure that you have a first render quickly, even if you don't have images, for example, at least the user will start seeing the structure of the page. Like, for example, they do that on Facebook. Like when you open something on Facebook, it gives you this outline, which is barely visible to you if it loads quickly. But it kind of tricks you into thinking that it's done loading earlier than it actually is. Because you haven't started, you cannot see the details in the few hundred milliseconds that it happens. So you're basically convinced that it happens quicker than it actually does. And interesting statistics are also the size of the page, which in this case is a whopping almost 2.5 megabytes. Well, so that's a bit much. And the amount of requests can also have an impact, although generally with HTTP2 these days, it's not that bad. In this case, like post-optimization, it's 26, 27, and only a half a meg, which is still a lot for a web page, but hey, It's 2019. You can also get a repeat view, which basically gives you an idea of whether you're messing up caching. In this case, you're not, because there's only one request that needs to be done in order to show the page again. So that shows you that the caching is working fine. So there's a few basic things that you need to do in order to get performance right, which are basically just server configuration, even though it's surprising how often it's not done still. You need to make sure, of course, that static resources are cached, basically just telling the browser, hey, you can keep this file for a longer time. I mean, is anybody unfamiliar with how to configure caching? Right, that's what I thought and hoped for. Pretty much the same thing, compression. It's a flag on the server saying, okay, you can send something, gzip compress it, so it takes less bandwidth. HTTP 2, I don't know how many of you went to the HTTP 3 talk? Right. So with HTTP 2, the problem of having many requests needed to build a page is a lot less important, because as opposed to HTTP 1, there isn't much of a performance hit when you try to request many files at the same time, because HTTP 2 allows multiplexing on the same connection, so you don't need a separate connection for each simultaneous download. And Keep Alive, well, that has been around since 1999 or 7 or something like that. But like 2 weeks ago, I was working on a customer site, and Keep Alive was not enabled, and that means that basically for each file, there needs to be a new TCP connection, new TLS connection, and a new HTTP request, which of course doesn't really add up to a pretty picture for download times for resources. Well, you can test that. You can test that on the command line using curl. Basically, you can check HTTP2, compression, caching, of course, if you check the headers on individual files. It's pretty basic. I mean, you get the results, and it will tell you somewhere down here. It will tell you that you're using HTTP2. Of course, you can see it even in the developer console in your browser. So that's pretty basic stuff. The more interesting thing is, in order to get really to the holy grail of performance, you want to get rid of all the render blocking CSS and JS. And that means basically after the browser has downloaded the HTML, it can show the page in its full glory. This is not something that's done very often because it's a bit of a pain. These days, if you're doing a JavaScript app with Webpack and such build tools, it's easier to integrate everything into the page, especially the CSS. But almost nobody does this for an actual web app. So that means that you always have at least the CSS request after the HTML is downloaded to deal with. And if you want to really do this, like to get like the minimum amount of time necessary for the first render, you have to put in a bit of work. For CSS, you have to find out what CSS you actually need in order to render a page, and not all the tens of dependencies you're adding to the page, but only the CSS that's necessary for that page, and put that inline in the HTML. And for JS, it's even bigger of a pain, because if you try to make scripts asynchronous, you'll notice that your current application doesn't work that way. And things are dependent on each other and dependent on all sorts of stuff. So it means you basically have to rewrite parts of your application in order to make that work. So your life is going to be like this. At least for me, it started looking like that at some point, that if I wanted to do these optimizations for my customers, I ended up having to do the same thing over and over and over and over again. And there's the added problem that if other members of the team aren't quite aware of why something is done a certain way, then they will undo your optimization. And then you have to do it again at some point. So suddenly you have another job. And especially if you're dealing with a legacy app where you don't want to rewrite everything, that's a problem. And God forbid, because I'm sure nobody of you are working with this, but God forbid if you're using WordPress. You don't have control over anything. There are all sorts of plugins, and every plugin is the most important plugin in the world, and every plugin wants to have a script and a style sheet on every page, regardless of where you're actually using the plugin on your site. So there you also kind of have a problem. So at some point, me and a colleague decided to build a tool in order to fix that. And we call it fast because it's going to make your site fast, and it's for PHP. So that's very creative. And I had moved to Bulgaria. I'm Dutch. I'm from here. But I had moved to Bulgaria like 4 years ago because I work as a contractor, and at some point I wanted to have an agency because I had so many projects that I thought, I should expand and I should have other people do the projects for me. But of course, that meant I had somebody at my an employee at my service. So that means that at some point I wasn't that interested in doing projects anymore. I was like, well, we're just going to spend a couple of months full-time building this tool without much of a business model. But hey, you are the guys that are going to profit from that. So that's actually Milko, my ex-colleague, because by now I'm working alone again, and he's also organizing PHP Bulgaria in November. Just wanted to throw that in. This software is so advanced that he did his master's thesis on it, and the people at the university were impressed. So the basic idea is, well, you have a slow page, you put R2. Yeah. I know I spent a couple of hours on this one, but all right, you get it. It's a little more complicated than that. It looks more like this. We're looking at the output of your page, and we convert that into we parse the page, but then we change a lot of stuff about its structure, and then we output the optimized structure of the page into HTML again to the browser. We do this on every request, and we try to do this as quickly as possible so that it doesn't really impact the performance, the response time of your server. In PHP, you've got ob start, and you can pass in like a function. And that function is then executed on all of the output that your page generates. So that's how it works under the hood. Empty slide for dramatic effect. So the idea is that instead of having to do the optimizations on your application, you just install this library, and you don't have to do anything, basically, unless there is some incompatibility that arises, which it does sometimes. And we can then add some new fancy features to the library and push that out. And you can update it so everybody gets to use the same optimizations without having to apply them to their application manually. The installation is pretty much just a composer install, and then you just call this function at somewhere you index PHP, like before your application runs. It's also possible to integrate it, like if you're using an MVC framework, you can integrate it as a middleware so that it operates on the response object in a bit of a cleaner way than using output buffering. So the most basic feature that we do is image optimization, which just changes the URL of the image to go to a service that optimizes the image, and if possible, outputs it as WebP if the user is using Google Chrome. And this way, we don't have to optimize any images ahead of time because we don't know which images are going to be accessed, but we just do it on the fly. On the first load, it causes a bit of a delay, but it's not too terrible. And of course, after that, it's cached, so there's no real impact on the server load after that. But in the course of doing this, this is very simple, of course. We're just replacing image stores, so you can do this with a regex. Of course, this is how I've done it in older projects, but at this point, we wanted to do a bit more advanced changes to the DOM, to the markup of the page. So we were using PHP DOM document, which works like this. I'm sure many of you have used it. It's very nice, but it's not HTML5 compliant. So I don't know how many of you think that this P is inside the div? How many of you think that it's outside the div? Well, you're all wrong, in fact. But PHP agrees with you, because in HTML5, there's no such thing as a self-closing tag anymore. Or rather, I didn't say that quite right. Self-closing tags are indicated by the tag name. And the slash, whether or not it's there, it doesn't matter. The slash is not interpreted anymore. It's not XML. So if you have the slash on a div, it doesn't do anything in HTML5. So that's how browsers parse this. They just parse this as a p inside a div. But when you use DOM document, it doesn't work. So we tried patching. This leads to problems, of course, because especially the legacy applications that I'm talking about, people are going to have weird markup going on. And it works somehow, and then you break it by using this tool. And then you try to do a bit more of client re-education and saying, yeah, it's broken because your markup sucks. So you're going to have to fix the application. But of course, nobody wants to hear that because it worked before. So you install the tool, and then suddenly it breaks. So it's not our application, it's your tool, right? So we needed to make it HTML5 compliant. So now I looked on Stack Overflow, and I thought, what's the best way to parse HTML? And it told me use a regex. So we're not parsing the whole page. We're tokenizing the page, and the regex is actually HTML5 compliant. So you can't we're not doing naive parsing with regex, but we're nevertheless using a regex. So I wanted to throw that in because you're not supposed to do that. And it's in fact a lot faster than DOM document because we're not building a DOM because a DOM is an object model, of course. Like you parse the entire page into a set of objects. Then when you're done manipulating, you output, you serialize the objects into HTML again. We're just looking at every tag separately in a stream. So that way we can output all the HTML that you have on your site. We can output it as soon as you output it to the browser. The filter doesn't need to wait for the entire document to be generated in order to start working. I wanted to look at how the critical CSS inlining actually works, both from an interesting perspective of how this library works, and also because you can apply this knowledge in your own project, even if you don't want to use the library. And why we're doing this, because if we inline critical CSS, we don't need to download the CSS when we open the page, especially if it's not in the cache. And we don't need to parse it either. We can render the page before downloading external CSS. So that saves us an extra round trip to the server. So the general problem looks like this, except worse. That you have a lot of dependencies on your site, and you have a very simple page that actually uses maybe 10% of all the styles you're loading. Like for example, with Bootstrap, people generally don't use everything. But if you don't make a distinction which rules you're actually using and which rules you're not using, you can try inlining your entire style sheet, but this is going to make your page very big, which is not going to help either. Because that way, at some point, you start not being able to fit the page in a certain amount of network packets anymore. And that's slowing down the load if you inline everything. And of course, you can forget about caching. So this is the general problem. You're only using like 2 rules, in this case, out of a style sheet with thousands. So what we do is we parse both the page and the style sheet, and we copy the rules from the style sheet that we need into the page. Pretty simple. And you can do this as well. There are tools for this. You can just Google that, critical CSS. There are tools that use a headless browser to load the page and then figure out which part of the style sheet you actually need to put on the page. Trouble with that is that you need to do that every time you make a change. So, well, I, for one, was not going to do that. Deferring JavaScript is a bit more complicated because it's not as simple as it seems, and it's not as simple as we wanted it to be. You want most of your JavaScript oftentimes to load after the initial render because it's not critical to the page. Even if you have a few components on the page that use it, generally the layout of your site is not dependent on JavaScript. So if you can get the layout, like the general, if you can get 50 or 70% of the visual content of your site to render without JavaScript, then that increases the perceptual load time immensely. So in that sense, it's pretty similar to CSS. So we can just do this, right? Except that you can't, because you're dealing with a number of problems in the difference between how async scripts or even deferred scripts are executed versus normally. The order is undefined. So if you do this, you apply this to your script, so you have a jQuery and jQuery plugin, they might be executed in a different order, and it won't work. Your application might be executed before the dependencies. Or it might work, but somehow something is going a little different than it normally does, and you don't even notice that actually something is broken. You can't use async on inline scripts, so you have to make them external, so that's a bit of work. Lots of scripts are dependent on DOM content loaded in such events. Like they only execute behavior after the DOM has finished loading. But if you use async, the script might be loaded after the DOM has finished loading. So the event will never happen, and the script will wait forever. So then, of course, your application is also broken. And lastly, although, again, I hope this doesn't apply to this audience, if one uses document.write, it's not going to work anymore because the way document.write works is that it injects the HTML that you output into the parser at that moment. And normally, when scripts are executed synchronously, the document is kept open, meaning that the parsing hasn't completed yet. And you use document.write, you inject something into the parser. But you can't do that once the DOM is complete. The DOM has been closed, so document.write stops working. So what we do is we load our scripts using completely custom architecture. Like we don't use the browser script execution mechanisms anymore. We disable all the scripts that are on the page, and then we download them using Ajax, and then we use eval to execute them. This is, of course, a horrible idea, but it actually works. Yeah, and in that sense, there's an interesting peculiarity to JavaScript that I'm sure that most of you won't be familiar with, but which I find very interesting. In this case, what's going to happen? Does anybody have an idea? Oh, yeah, actually, I'm an idiot. I should have, yeah, you're right. Let's say that it actually said var a instead of a. Yeah, if it said var a, of course, it wouldn't log 5, it would be undefined. But if you normally have this script like in global scope, even if it's a var, if it's executed in global scope, it will also populate the same variable in global scope, like on the window property. Because when you're running something in global scope, like your scope is the window property. So this doesn't work. And of course, the way that we're executing scripts, we need this to work. But luckily, there's a trick that looks like this. And when you use eval like this, again, imagine that it says var a, not a. When you use eval like this, it's called an indirect evaluation, which basically is triggered by whenever you use an expression to access the eval function, or you assign eval to another variable, and then you use that variable instead of the original eval. So when you access it indirectly, which is defined in the spec, what indirectly means, then it actually runs in the global scope, which is retarded, but it's part of the spec, so we should be happy about that. Regarding the events, what we do is we overload the properties in the browser that scripts use to determine whether or not the loading has finished yet. Because jQuery, for example, checks the ready state, and if it says, OK, ready state is complete, then I will start executing my scripts right away. Otherwise, I'm going to wait for the DOM content loaded event. So we need to mask the ready state as well. We're not sure when the onload event happens, because that depends on when images are loaded. So it might happen during script execution or afterwards, or before. So what we do is mask the onload event, like stop it from propagating to any of the event handlers that are installed by the scripts. And then we run the scripts using eval again. And then we clean up after ourselves and trigger those events manually. The trigger event function is not in the browser, but that's just it takes a couple of lines in order to trigger an event, so that's why I didn't put it in here. For document.write, it's another gem. It's a little more complicated than this. For example, if you document.write a script, you also want the script to run, and there's a couple of other edge cases. But generally, we mask the document.write function, buffer everything that you're trying to write, and then after the script has executed, we insert it into the DOM manually. So that things kind of end up working more or less as they did before. And remember the thing with Google Analytics? So Google Analytics uses a script to insert another script dynamically into the page. And what we want to do is we want to proxy it on the server side so we can extend the cache duration. But we can't do that easily because we don't know the SRC of the script before we insert the loading script into the page. So we override append child so that we can filter all of the insertions into the page and change the SRC. Pretty, isn't it? Well, there's a couple of more features, but I'm not going to go over that because this was the most interesting part. Removing comments, and what else did we not cover? Inlining small images like logos and little buttons that you don't really need to load externally because they're only a few K. And if you have iframes like Google Maps, YouTube, then those are delayed as well. So what you get with this approach is a very fast first render, which on most sites works very well because none of the functionalities or none of the visuals are dependent on JavaScript. And people can start looking at the page and deciding what kind of interaction they want to do before it's actually finished loading. Well, it also really helps with the PageSpeed score, so this is a bit of a psychological thing because generally the PageSpeed score, of course, is not that important, but it does help with that. And it saves bandwidth due to the image optimization and minification, although those are things that you can easily do without such a convoluted approach. Of course, the best place to use this, like I discussed, like when you're not in control of the application, like if you're using WordPress or CMS, or if you don't have the time or the will to actually dig down into the application and change stuff. Downsides are there, of course. It takes about 60 to 80 milliseconds to do the processing on the server side before outputting the page. Debugging is a little more difficult because of the way that scripts are executed, so you don't know where an error is. It's pretty easy to overcome by just disabling it for a second. You can do it with a URL parameter. And if your application is dependent on JavaScript for the rendering, then it's not going to help you because you need the JavaScript to execute, so then you're on your own. Yeah, I wanted to go over the comparison to mod PageSpeed, but we have only 5 minutes, and I don't know if there are any questions, so I'm just going to leave that in case there are no questions. So there's a GitHub, of course. You can just compose and install it. It's GPL. And for WordPress, there's a WordPress extension plugin, which is actually used by like 800 people now, which is not a lot, but it works at least. Like if it works on WordPress, it should work on your application because it won't be much more fucked up. So that's it, basically. Questions? Yeah, so the question is regarding the CSS optimization. If I have a script on my page that then creates markup that uses a CSS class that's not in the optimized CSS because it wasn't on the page originally, will that still work? And the answer to that is, of course, yes. That will still work because the way it works is that we send the initial optimized CSS for the initial render, but immediately after that, we also fire an asynchronous request to get the original CSS, and we replace the optimized CSS with the original CSS in the page before executing the scripts, if that makes any sense. Any other questions? All right. Well, actually, I don't know how many of you are familiar with mod PageSpeed. Have any of you used this? Yeah. Well, it's a server-side module for Apache Nginx that basically does a few of the same optimizations, a few different ones. And I've used this before we started working on this PHP tool, and it actually works. It works okay. There are a couple of downsides to it that made me decide that we wanted to do it differently. First of all, mod PageSpeed works probabilistically with some sort of budget situation. Like it decides based on all sorts of metrics whether or not to perform a particular optimization at a given point. And you can configure that away, but it's kind of complicated. We wanted to do something that does all the optimizations every time because we wanted to go for that perfect score. And besides, with the PHP solution, it's PHP, so it's easy to edit. It's not C because PageSpeed is written in C. You don't have to compile it for your web server, so even if you don't have access to the server, you can easily configure it without that. And that also causes it to just be easier to set up because you just do Composer install, you're done. You don't have to worry about configuring it for Apache Nginx. It's also kind of painful to update your web server when you have mod PageSpeed installed. So yeah, all right, I think that's it. If there are no more questions, then we're done.